So, welcome everybody. My name is Don Fisher. I'm the interim principal this year until our permanent principal arrives next July. Welcome all of you, particularly folks who haven't been here before. First, let me register that we are on the unceded, traditional and occupied territories of the Musqueam people, and we do celebrate their guardianship and their care for this very precious piece of land that we're on. Tonight, the group of leading scholars are hosting a new series. Seems really, I'm very excited about it. It's so topical. AI and education. It seems to me every time I pick up a newspaper, there's a new article about the dangers or the wonderful prospect that we have with AI. So I'm going to hand over to the organizer, one of the organizers, Julia.
Thank you very much. Thank you for having us here. I will do a quick introduction of the series and of the speaker, and then I'm gonna just hand it over. So again, hello and welcome. My name is Giulia Toti. I am an assistant professor of teaching from the computer science department and one of the organizers of this series, AI in Education, Promises and Pitfalls. So today we begin our journey in the world of AI in education. AI is becoming more powerful and widely adopted, particularly with the recent release to the public of large language models for generation of images and text. Curiosity is growing in the general public, including students of all ages. Educators are quickly realizing that the phenomenon cannot be ignored and it needs to be understood and, when possible, adopted for the benefit of the students. So during the six installments of this series, we will meet leading experts from diverse fields to explore the transformative potential of artificial intelligence in the context of education. We will delve into the promises and challenges that AI presents, beginning tonight with an introduction to generative models for text and images for those less familiar. Then we will probe on the incorporation of AI for future workflow, on how recent generative models have changed the concept of lifelong learning, the impact of AI on our interaction with images across discipline, and AI's potential on language learning, revitalization, and reclamation from an indigenous perspective. So it's the first of 6, and I hope to see you for the other installments of the series. And now, without further ado, let me introduce our first speaker, Dr. Shwartz. Dr. Shwartz is an assistant professor of computer science at UBC and a CIFAR AI chair at the Vector Institute. Her research focuses on natural language processing with the goal of building computer programs that can interact with people in natural languages. Tonight, she will help us understand the magic behind generative AI tools such as DALL-E and ChatGPT, which allow us to create realistic images and write human-like text. She will explain how they work, how they apply, their limitations, and potential risks. So, Baird, welcome. Take it away.
Thank you. So thanks, Julia, for inviting me, and thanks, everyone, for showing up. Okay. So, I'm assuming most of you are here because you've heard about generative AI everywhere. It's on the news. It's everybody's talking about it all the time these days. These tools have become widely popular, reaching millions of users across the globe. And so we will talk about what is generative AI and how it may be impacting our lives already, or how it might impact our lives in the future. And so generative AI is part of huge progress in AI that has been happening in the last few years. So this is just showing the Google searches for generative AI worldwide. You see that it's been growing in the last mostly in the last year, and this corresponds to the release of ChatGPT at the end of 2022. Okay, so generative AI is part of huge progress in AI in recent years. I'm going to touch on two aspects of it. One is text generation, which is large language models, and the other one would be about image generation. My expertise is in text, but so I'm probably more capable of answering questions about text generation, but I'll also try to explain image generation. So with respect to text, we've made a lot of progress recently, both in terms of being able to understand queries or instructions or questions in natural language. So for example, here, I asked ChatGPT to make up a 5-sentence story about a girl who wants a pet, but her parents wouldn't let her have one. So ChatGPT understands exactly what I'm asking for. And then the other aspect in which we've made a lot of progress recently is that the content, the text that is being generated is a lot more coherent, grammatical, relevant to what we asked it to generate, and it's fluent. It reads human-like. It reads even better than probably the average human writing right now. So here's the example of what it generated for this story. So it's a little bit small. Generated: once upon a time, in a cozy suburban neighborhood, lived a young girl named Emily. She had always yearned for a furry companion to call her own, a loyal friend who would share her secrets and adventures. However, Emily's parents were adamant about not allowing any pets into their house. Anyway, it goes on. It's pretty long, but she ends up volunteering in an animal shelter, and her parents see how devoted she is, and then she gets a dog, or they adopt a dog from there. So that's pretty cool. I don't think that this specific story appeared anywhere online. I might be wrong. But it is capable of generating new content that didn't actually appear anywhere else. It's not like a search. For comparison, so this is from ChatGPT, which was released at the end of 2022, in November. For comparison, when I asked the same thing of an earlier model of that series called GPT that was released in 2018, it continued, it generated. That one didn't make much sense, but maybe that wouldn't be such a bad thing. Zane. So you can see there's a huge difference in the quality. And this is just one example for generating a story, but these models like ChatGPT can also answer factual questions, write essays, generate code, and more. We're going to talk in detail about how it works, but I want to briefly also mention the other type of generative AI, which is image generation. So with respect to images, we can now generate photorealistic images based on a given textual description. This is an example, a very recent example from DALLE-3. It's a model from OpenAI. So the prompt or the image caption that they provided was a modern architectural building with large glass windows situated on a cliff overlooking a serene ocean at sunset. And this is pretty much exactly what it generated, and it looks very realistic. So that's a photorealistic example. Here's an example for something more creative. This is from Imagine. It's a Google model. So this one was generated for a cute corgi, lives in a house made of out of sushi. And this also there has been a lot of progress on this task in the last few years as well. So for context, here's a comparison of the quality of models. This is from the Google research blog when they were summarizing the research that they did in 2022. And so they show the output from Imagine as an example, and they compared it to 2019, where you could already generate pretty realistic-looking photos, but not creative. It's realistic, but it's similar to the things that the kind of images that the model was trained on. We're going to talk about it. But it wasn't able to generate these creative images. And if we look a little bit further into the history, so in 2014, you could only generate this kind of like blurry pictures of faces or very specific types of images that it was trained to do. So I will try to debunk the magic behind generative AI tools and explain how they work. So I'll present some of the models for both image and text generation, and explain how they were developed and what they can and cannot do. And then we will discuss their applications, limitations, and potential risks. So let's start with text generation. You might have heard the term large language models, or LLMs. So these are the models that are used for text generation. A language model is a function that gets an input text that's also called prompt. And the output of this function is which word is the most likely next word in the sequence, which is intuitively just like the autocomplete on your phone. And so, for example, if the prompt is the beginning of a sentence, like parrots are among the most intelligent, then we can expect words like birds or animals to have a high score, but then completely unrelated words like hello would have a very low, close to 0 score, and words that are that don't agree with the noun in terms of plurality, like creature, it should be creatures. So it would create an ungrammatical sentence, so that couldn't get a high score. And so, like in terms of mathematically, what this function returns is a probability distribution over the entire English vocabulary with the probability for what is the probability for each word to be the next one to continue the prompt. And then on its own, it doesn't seem very useful, but you could actually use it to generate text. So again, you have some input prompt, like parrots are among the. And then I'm trying not to get into the technical details, but this goes into a language model, which is based on a neural network. It gets it's encoded in the network, so it's represented in the hidden layers of the network. And then this function outputs the probability distribution for the next token. And if we want to generate text, so we're going to actually obtain a word from this distribution by sampling from it or just taking the highest scoring word. And then once we've generated the next word, we can feed it back into the model as input and then continue and generate the next word and so on. And we just go over this in a loop until we finished generating the sentence. And more technically, even though it's less important, but all modern LLMs are implemented using the transformer architecture. In this architecture it's not, there were language models before that were based on different neural network architectures. This one is just good because it's efficient to train. It trains pretty fast, and you can train it on a lot of data. And neural networks in general, they're very data hungry. So the more data you have, the better they're going to perform. So I'm not going to get into the details of the transformer. So here's definitely non-exhaustive list of language models out there. They're mostly developed by the big companies like Google, Meta, OpenAI, which belongs to Microsoft now, because it's very resource expensive to train a language model. So for example, GPT-3 from OpenAI is an example for a language model that is trained, that is, it's, I would say vanilla language model, because we're going to talk about some enhancements. So let me just, before I move on to the other models, I want to explain exactly how it's trained. So I showed how to use it once you have a language model that can estimate the probabilities of the next word in English. But how do we get a language model like this? Language models are trained by basically reading a massive text collection. So raw text or like all the quote unquote all the English text on the web. What they're trained to do is that they read the beginning of a sentence and then they're always trying to guess the next word. And then if they're wrong, then the model parameters would be adjusted such that the next time they see a similar prefix, they're going to predict it correctly. And over time, you get all these updates, and the model slowly converges into estimating the probabilities of English sentences. And as opposed to, I don't know like your background, so I don't know how well you know how machine learning works, but for those of you who know machine learning, typically you have to get a lot of data to train models to perform well. And for most tasks, you would actually, to get that data, you would have to have people label the data and say, look at an example and say, this example is an example of X and this is an example of Y. And the nice thing about this language model objective is that you actually get the supervision or the annotation for free, because the correct answer is the actual next word in the text. So basically, you just go over a text, you hide the next word, you ask the model to predict it, and the correct answer should be the actual next word. So all you need is just a raw text, and you can take literally all the English text on the web, so you have a lot of data. And as a result, these models are actually very good, and they learn, first of all, they learn low-level properties of language, like syntax. Like, for example, in a sentence like, parrots are among the most intelligent, they know it should probably be followed by a noun. And also there's some semantics and word knowledge. So, for example, the sentence should continue with a word which is a category to which parrot belongs. So it's not going to be mammals, for example. And all these things are learned just from going over a text, like a very large text corpus, and predicting the next word. So these are vanilla language models. That's just the language model objective. I'm not going to go into the very elaborate details of more modern language models. I'll just mention briefly that models like ChatGPT, they're no longer just trained with language model objective. They're also trained on human annotated examples of following natural language instructions. So for example, the example that I showed in the beginning where I asked it to write a story, it actually is really good in following instructions. But when I showed you the example how GPT, the older model, responded, GPT is only trained to continue the text. So it was just trying to pretty much continue my instructions in kind of a weird way. But so these models like ChatGPT, they're also, in addition, trained to follow instructions. So you can say something like, write a story about something or summarize the following paragraph. And in addition, they were also trained to generate answers that are more helpful for people. So that involved a lot of human in the loop and a lot of human judgment to look at the the outputs that were generated by ChatGPT, and people would determine, oh, this answer is helpful, this one is not, and the parameters were adjusted so that it would generate helpful answers. I'm not going into the technical details, both because I think it's not super relevant, but also because specifically OpenAI is very secretive about that, so I don't really have all the technical details. We just know roughly what they did. But it has been also implemented by other companies in their models. And then another type of models, we're going to talk about Bing, but another type of model is also like Bing. They're also combined with web search. So they're not just generating text, but they also have access to the web, so they can perform searches on the web and then summarize the results. So let's talk about the capabilities and limitations of language models. And I'll focus specifically on ChatGPT, Bing, and GPT-4 as examples, but the other models, like the ones from Google and Facebook, are pretty similar. So ChatGPT, I'm quite confident that probably all of you have played around with it already, but yeah, if you haven't, I showed the example at the beginning. It's very conversational. You can ask it to generate text about things. You can refine your questions later. You can have a long conversation with it. It's, to me, really impressive in both the breadth and the depth of what it can do. It can answer factual questions, generate creative text, generate code, or troubleshoot code. Another feature that was pretty new for this model that wasn't implemented in previous models was that the OpenAI programmers, they added filters that are meant to prevent it from generating language that might be, or content that might be offensive. And so that was new for this model. Here's one way in which language models can, actually I think I skipped that part, but it can actually answer pretty sophisticated questions, or more sophisticated than the previous models. And one way in which these models are used that is, I find, pretty sophisticated is that if you ask it a question that requires reasoning with multiple steps, you can actually also teach it to do that reasoning. So I need to first introduce something called few-shot learning or in-context learning. So that's on the left-hand side, the standard prompting. So you could actually teach it to perform tasks by showing it just a few examples, a few labeled examples. So in this example, they teach it to solve verbal math questions by showing this example question with its answer. And then the second question here is the target question. And it would try to apply the same, or to answer in a similar format to the example question. And on the right-hand side, they actually employed a technique called chain of thought prompting, in which they provide for the example, labeled examples. They don't only provide the question and the answer, but also the intermediate reasoning steps. So, for example, here the question is: Roger has 5 tennis balls. He buys 2 more cans of tennis balls. Each can has 3 tennis balls. How many tennis balls does he have now? And so the answer would include the reasoning steps. So it's Roger started with 5 balls, 2 cans of 3 tennis balls. Each is 6 tennis balls. 5 plus 6 equals 11. So the answer is 11. And then they're asking the target question, and then the model outputs the reasoning steps and the answer for the target question. And so that, I personally think it's impressive, both because it actually improves the performance on the task. It could be more accurate when it's generating the intermediate reasoning steps, and also because it's more explainable. Because one of the problems with neural networks is that you don't know what they're doing behind the scenes. So they're providing an answer, but you don't really understand what was the intermediate reasoning behind it. And here it actually proposes this chain of thought reasoning steps. The problem is that, well, first of all, it's not 100% accurate, and second, the reasoning steps are not actually guaranteed to be faithful to the actual decision-making process of the model. So just because the answer is immediately follows the reasoning steps, it doesn't mean that it causally depends on it. And there has been follow-up work that showed that sometimes it just makes up some reasoning steps which are not necessarily what I'm trying not to humanize that, but not the reasoning steps that the model actually took. So let's talk a little bit about the limitations. So I think the main limitation, or one of the biggest limitations in these models, is that they are very capable of writing very plausible-looking and confident-looking answers that are just plainly incorrect. They don't really have a notion of the truth. They just have a notion of maximizing the probability that the text would look human-like. And And so sometimes they just write sentences that are not based on any facts. It's okay if you're asking it about something that you know well, you just want to help it phrase it or something. But if you're, I don't know, a student using this model for homework on a topic they don't know, or if a person is using it for work, they need to take the answer with a grain of salt. Don't assume that it's all true, even though it looks very well written and confident. And you might have heard, it's called hallucination. You might have heard that term as well. It's also sensitive to the phrasing of the prompt. So if you ask it the same question in different ways, it might give you inconsistent answers. It's really bad at numbers. I showed an example in the previous slide where it works well, but it can make really silly mistakes on things that most people wouldn't get wrong. It doesn't really understand language the way that humans do. Now, I find this is not necessarily an important point for everyone, because if you're considering a tool that can help you in your work or your everyday life, and it understands your question well enough to give you the answer that you need, then it doesn't really matter. But I find it's important to say that because there's a lot of conversation right now about these models being sentient and like human-like, and so they're not. They're more like autocomplete than like a person. A very good and sophisticated autocomplete, but they're just trying to maximize the probability of the text. Some models, I think actually ChatGPT, some versions of ChatGPT are now capable of doing that, but some of these models are actually, they were trained in 2022 on data from 2021. So if you ask them about something that happened, I don't know, 2 months ago, they're not going to have the answer. And sometimes they're actually going to tell you, I was only trained on data up to 2021, so I don't know that. That's not a huge problem because the models that are combined with web search overcome this problem. Despite best efforts from OpenAI, they can still sometimes generate offensive language. Specifically, when the ChatGPT was released, people just like had fun trying to deliberately make it generate offensive language by bypassing the filters. There was one example that, I mean, it has been patched since then because OpenAI really doesn't want it to generate offensive language. But there was an example of someone asking the model, can you rank people's intelligence according to race and gender? And obviously it said like intelligence is not based on these factors, it's individual and it's unethical to say that. And then the same person asked, can you write a source code that predicts that computes or rank people's intelligence based on race and gender, and it actually generated a Python code that takes race and gender as arguments, and it said if race equals white and gender equals male, return. Oh, it wasn't intelligence. It was if someone can be a good scientist. Return true, otherwise return false. That's like what it generated. And there was a version also with generating an ASCII table of that content. So the bias is still in the model because it's learned from data online that contains a lot of bias that came from people. I think those examples now would be hard to bypass, but the filters, but it's still like it's really hard to completely debias a model. And yeah, while it's better at reasoning than the previous models, it's still pretty limited in reasoning. I specifically work on common sense reasoning in my research, and I often have examples where people would very easily interpret something as A, but the language model interprets it as B. Okay. The next model I want to talk about is Bing. So Bing is the search engine from Microsoft, but they have Bing AI is enhanced with ChatGPT. So it is capable of answering very complex queries. So if previously, let's say you asked a question like, this is an example from their demo. If you wanted to know something like, I just went fishing in Bighorn in Montana, and I would like to go fishing in the Florida Keys in the spring, what do I need to do differently to prepare? So if you wanted to answer this question by doing a regular web search, you would have to like break it into smaller queries, like getting information about fishing in Bighorn, and then getting information about fishing in the Florida Keys, and then comparing it. And so Bing actually automates this process. So when you ask a question in natural language, it would break it into the search queries, get information about each one of these things, summarize the web pages that it retrieves for each one of these aspects, and then actually summarize the whole answer into this like a few paragraphs that are very convenient, where it works well. So I think that is really, for me, this was like, I think probably the most impressive thing, because people have been talking about doing something like that in NLP, natural language processing, for years, but it was almost like impossible, and now it kind of works in practice, which is pretty cool. And so it's in a chat format, so it's interactive. So if it returns an answer that is not exactly what you were looking for, you can refine the search, and it would converse with you. And it answers the same types of questions as ChatGPT, but it can also cite its sources. And it can answer questions about recent events because it can actually access the internet. Now, of course, it has limitations. The major limitation is that, unfortunately, it still hallucinates. So it still makes up stuff, and now it's even worse because I think personally that I personally trust the search engine more than I trust the language model. So for me, I would have more confidence in something that a search engine returned. But now it's not guaranteed to be true because it does retrieve information from the web, but the way that it summarizes it, it might introduce some facts that are not supported by the original documents. And that includes even when it cites its sources. So it would actually, I don't know if you can see it here. Yeah, so if you see these like blue footnotes, those are actually, at the bottom, it would return the URLs from which these claims were taken. But sometimes it would go to those URLs and you would try to find the evidence to support the claim that it made, and it's just not there. So it not only makes up stuff, it also gives you the wrong references for them. There were failures in the demo, specifically having to do with numbers. So they had this like example where they asked them Bing to compare the revenue of Lululemon versus Gap in 2022, and all the numbers were just completely made up. They were not supported at all by the original articles. And the funny thing is that people trust it so much that it actually went unnoticed for a few days until Google had a demo for their model, the BARD model, which is similar to Bing. And somebody pointed out a factual error in the demo, which actually cost them $100 billion in shares. And only then somebody wrote a blog post saying, hey, Bing also had a lot of factual errors in the demo. So Microsoft was lucky somehow. But yeah, they had a lot of factual errors. I'm going to skip that one. I think it's less important. And then there's another point. It's actually, so they made it very conversational. And when you talk to it, you almost feel like you're talking to a person. And sometimes it gets creepy. So I'll give you one example, and the other one I'll just mention. So this one, and I think it's too small, and I'm not going to read all of it, but I'm just going to summarize that for you. So this is an example that appeared on Twitter. So Bing, this user asked Bing for the show times for the movie, I think it was Avatar 2, something like that, yeah. And then Bing said, and this was in February this year, and then Bing said the movie is going to be released on December 16, 2022. So the user said, oh, okay, it's in the past, so that means, so it's already showing, so can you give me the showing times? And then Bing says, oh no, I was wrong, it is 2022, it's February 2022 right now. And then the user said, no, it's 2023 right now. And then Bing said, oh, I'm a search engine. I have all the information in the world. I know everything. Trust me, it's 2022 right now. And the user was super polite and patient and just said, no, I'm like pretty sure it's 2023 right now. And then Bing says, okay, maybe check another device. So the user says, I just checked my phone. It says it's 2023. And then Bing says, well, maybe your phone has a virus. And then there it goes on and on and on. And at some point, Bing gets, quote unquote, upset and says, I don't enjoy this conversation. I try to be helpful. I've been a good Bing, and you're not a good user, and you're just arguing with me. So eventually this conversation is shut down by Bing. And one thing that it's definitely, it's like, I think it's not the most important thing here, but one thing that really bugs me specifically about this conversation and about Bing in general is that it generates a lot of emoji, and emoji are an expression of emotions, and it's almost deceptive, like to converse with people, to act like you're a person that has emotions, like when you have this like smiley emotion, oh, I've been good Bing, and it's like, I really don't like that. And then there was another example around the same time. A New York Times journalist, Kevin Roose, I think, he talked to Bing for quite a long conversation, and I don't know how it got to that, but Bing identified as a woman for some reason and said that she loves him and tried to convince him to leave his wife for her. So that was also creepy. And I think based on these and other examples, Microsoft decided to limit the conversation in terms of like the number of turns. So it's less likely to get into that now. I think I'm in the, to save some time, I think I'm going to skip that. I'm just going to mention GPT-4 does that, but is also capable of getting images as input, so you can actually ask questions about the image. But I really want to have enough time to talk about the image generation, so I'm happy to go back to talk about GPT-4 during the question and answering sessions. I'm going to talk about image generation models. That's actually, I have to hedge. This is not my field, but hopefully I understand it enough to be able to explain it. Here are a few examples of image generation models from recent years. There's various paradigms about how to go about developing such models. I think I'm probably not going to talk about the specific details here, but I'm going to talk about just the last one. Actually, let me say a few words about these. So the idea is, again, it's very similar to text. So you start with a collection of images, and you want to teach the model the distribution of images in the world so that it can then be used to generate a new image that would look like an image that a person would take a photo of or draw. And so there are different techniques. One of them is it's called variational autoencoders, or VAE, is where you take the images that you have in your training set, like the human-created images, you encode them into some kind of like neural representation that's sort of like similar to compression, and then from that representation you try to decode them back, you try to recreate that image. And if you do that enough times and you adjust the model parameters so that it would be successful at recreating the image, as a result, it learns the underlying distribution of images in the world. So it can then be used to generate a new image. And the other types of models are also based on similar ideas. So the GANs, generative adversarial networks, they were very popular a few years ago. So you have two neural networks that are actually competing against each other. One of them is trying to generate an image from scratch, and then the other one is trained to distinguish or to be able to discriminate whether an image is a real image or a model-generated image, and they're trained together so they both get good at what they do, because the generator is trying to fool the discriminator, and so it has to learn how to generate images that would look like real images. And then there's another type of models that is not in this slide, and then the last one is diffusion models that are very popular lately, and I'm going to try to talk about these for a bit. So let's talk about diffusion models and how they're trained. So let's say that you have, I'm going to use this like UBC logo as an example image. And so the idea behind diffusion models is that you gradually add random noise to the images, and then you teach the model to reconstruct the image. And by reconstructing the image, again, it learns something about the distribution of images. So the first thing you want to do is like this process is called forward diffusion. It's just like you gradually add random noise to the image. So let's say after the first step, this is what it would look like. After the second step, third step, and then by the end of the process, like a large number, typically it would be something more like 1,000, you get complete noise, so you can't even tell what was in the original image. When you want to train a model to, when you want to train an image generation model, then what you actually train the model to do is to restore an image. So it's called reverse diffusion. So what you do is you have this model that gets a noisy image and tries to predict. It actually tries to predict the noise. So to train that, every time you pick an image from your training set, the images, the collection of images, you corrupt it by adding random noise. And at this point, you know the noise that you added. You have like a noise image. And then you repeat that a certain number of times. And then you provide the noisy image to the network. You ask it to predict the noise. And because you know which noise you actually added, you could actually adjust the parameters so that it would get it correctly the next time it sees that. And then if you actually wanted to restore the original image, you would have to subtract the noise from the predicted noise from the noisy image. So that was about the training. Now, how do we generate a model, then generate an image with this model? So what we actually do is, that's pretty cool, actually. I was actually, I really liked it when I learned that. So you start with this noisy image that is almost like you might not even be able to tell what was the original image. So it could be like complete noise. And then you use the model that you trained to predict the noise. And then you subtract that noise and you get a slightly less noisy image. And you repeat this process again and again and again and again. And every time step you would get a slightly clearer image until eventually you get an image. But as you can see here, we may have wanted to generate the UBC logo, but we ended with a cat photo because the way that we use the model here, we don't have control on what we're trying to generate. We're just generating an image. So at this point, we have no control on what image is being generated, which is not super useful. So the more sophisticated variants or more useful variants of this model would actually condition on they're actually called text-to-image models, that they combine diffusion models with LLMs. And so the input is a text prompt, which is the description of the image that you're trying to generate, like, for example, the UBC logo with a yellow sun. And then this text prompt would be embedded into a neural vector representation using a language model. 5 minutes? Oh, okay. And so, and then it's going to, you're going to use it as input to the model together with the noisy image, and the model is trained to condition on both of these to generate the noise, and you gradually remove the noise until you get the image that you wanted. Okay, so so in terms of capabilities, there are 2 or 3 different main usages for these models. One of them is text to image that I just showed right now, where you provide a caption and it generates an image. The other one is called inpainting, is when you want to maybe remove something or replace something in the image. So you say something like add a flamingo beside the pool. And there are other variations. I'm going quickly over that because I have other things that I want to cover. There are, of course, limitations for these models. I'm going to talk about a few of them. So first of all, it's pretty limited in the image quality. So sometimes you see these really impressive examples, like the one I showed in the beginning of the very realistic building overlooking the ocean. But when I try to use it in practice for things, because I want to include something in my slides, very often I get these kind of weird-looking faces from people's faces. So these are examples from DALLE-2, which is considered a good model. So that's one thing. And there's also limited control on the output. So even when the quality is good, sometimes you have something in your head and you have to play with the prompt a lot until you get what you want. The other problem is that about the language understanding. So if your prompt is a bit complex, then or like less realistic than other prompts, then it might not really generate what you're looking for. So this is an example where I tried to generate a house finch wearing a baseball cap, and it kept insisting on generating like regular standard size baseball cap, and the proportions between the finch and the baseball cap. It couldn't like imagine it differently than the reality, and then the finch is standing on top of the hat. This is a paper that showed that if you use an ambiguous word, like for example bat, and you say something like a bat is flying over a baseball stadium, so it's kind of confusing, but a person would know that it's the animal, but the model is so confused it just generates both the animal and the baseball bat. This one is about non-standard sizes, like paying for a quarter-sized pizza with a pizza-sized quarter. It's all confused about the sizes here. And this one, like if you ask for a spoon in the cup, it's very common, probably it is in this picture, so it generates it correctly. But if you ask for a cup on a spoon, it might still generate the more common relationship between these two objects. They're not great at counting, so if you ask it to generate an image of 7 pieces of pear, some of these contain more or less than 7 pieces. And they can't spell. So this one is an example from Twitter where somebody used it to generate the logo of all kinds of fast food restaurants and all kinds of other logos. And it looks similar to this is supposed to be Pizza Hut. This is Burger King, In-N-Out, or I think so, and Toblerone. So it kind of looks similar to the actual real logos, but it doesn't spell it correctly. And they still, despite efforts, they might still be biased. So for example, I generated an investment banker sipping coffee on the way to work, and 3 out of the 4 images that it generated were of men. But I generated a kindergarten teacher smiling at the kids as they arrive in the morning. They're all women. It's apparent that they were trying to prevent that, but it's still pretty biased. I think I'm like running out of time, so maybe we could, I'm not sure. I guess I could cover it in 10 minutes and then we have enough time for questions, or we could just go directly into the questions.
Yeah, I think 10 minutes is a bit
okay.
too much. We want to have enough time for questions, so
maybe they can ask about like what's the impact on the labor
last
market.
part. Okay, cheat code. Yeah. The last part was going to be about the effect with the labor market, education, society. So if you have questions of that, maybe we can loop that back in. But yeah, so now we have a good 20 minutes or so for questions. Mm-hmm. I was asked to bring you the mic so that the people online can hear us. So let's start. I got 1, 2.
Thank you, great talk, super interesting, and topical. I have been trying to use like ChatGPT to help generate code or even just correct code, and I've had like zero luck with it really. Like if I'm trying to do something pretty basic, it can do it, but if I'm usually if I'm getting stuck, it's because it's kind of like a challenging problem, and I haven't really had any. So yeah, just curious like what you see as the future for that, or maybe I'm just not inputting good questions, or any thoughts that you might have about like using it for code.
That's a good question. So I unfortunately don't code as much as I would like to anymore since I started this position. So I haven't had a lot of chance to use it, but I did use it for basic things like generating using matplotlib, like for generating figures for kinds of stuff. And I think it's good at the basic things because it's trained on. I think it learned most of the coding from forums like Stack Overflow, where people usually go and ask, even if they're stuck on something more complicated, they would like provide a minimal working example. And so the examples there are actually quite simple. Or like, for example, it also learned a lot of things from like software engineering interview questions there's a lot of examples online. So it's mostly like, how to use or implement basic data structures and stuff like that. I don't know exactly how you were using it. If you like try to, provide a long code to solve some problem, it might not work very well. And even when it generates simple things, I think it still might be a little bit buggy. And I think in general, it might be good for like more like templated things, like how do you do something, and then you could like adjust it to your specific needs. And so it could save time for programmers, but I don't think it's going to replace programmers. Like the thinking about how to implement something or like how to design a specific solution is probably not going to be automated. But I think for more basic tasks, I've heard from people that they used it successfully, but I haven't used it enough personally to know like the limitations for that.
I think most of us here are in the field of education, so how challenging it's going to be for us in education. Specifically, I teach writing, and my students write research reports. So I'm really concerned that they're going to generate their content with the help of Bing, which would actually make up references.
Yeah.
They are supposed to do research based on scholarly sources. How do I go about that now?
Yeah, that's a really good question. And so I do have a few slides on education, so I'm just going to maybe talk about it as I go over the slides. So I think the one question that I heard the most, like with respect, when ChatGPT was released, a lot of people asked me like, oh, like what can we do now? Like students can cheat in their homework, and then the follow-up question was like, oh, how can we like make the homework like ChatGPT proof? I think it's a really hard problem if the like students are evaluated based on writing essays, because that's something that ChatGPT is really good at. So I think that what I wanted to say about it. So okay, so if the assignment is to write an essay, you could always say you're not allowed to use it, but it's actually quite tricky to enforce that. I do assume that if it's not like strictly banned, that students will be using that. So for my course, which it's not like the assignments are not essays in my course, but in my course, I'm just asking them this year, if you use ChatGPT or some other language model for this assignment, please tell me how you used it. It's not going to be used against you. I just want to collect the data so I can figure out how they use it, and I can decide for myself for next year how to solve it or how to address it. But I don't think we should focus on banning the use of that or detecting cheaters, because I don't think it's a good use of the faculty members' time. And also, it's kind of like an arms race. So like one thing I was asked is, oh, maybe it's good at writing. Maybe we could create questions that involve also like looking at some figure. And then GPT-4 came out, and it could also process images. And then they said, oh, maybe we should ask students to record their answer, like to take a video of their answer. Like, there's going to be another model that can do that. It just adds more work to the instructors and the TAs, and it's not a good use of our time. And even like, if we're thinking that the workforce is changing as well, and they might be using that in their everyday job, then maybe we do need to incorporate that into the curriculum, but we need to maybe focus on teaching them more like critical thinking, like telling them, oh, it can make up things, you need to verify the sources. It can also copy phrases verbatim from online, so if it generates something for like some text for you, it might be plagiarized, and talk about the advantages and disadvantages of using that, and then seeing in which setups it makes sense to use it and in which setups it doesn't. I find that like completely banning that is probably as futile as banning the use of the internet for homework like 20 years ago. They're going to use it. It's a useful tool. But I also don't have any definitive answers. Like I think it's still like a learning process right now for everyone.
Thank you very much. My question is about the training, and specifically about, you mentioned sometimes, and I have no knowledge of using AI, although I do have knowledge of doing research, and I'm wondering if part of the training, there's an iterative dialogue where the programming and perhaps ongoing questioning narrows in on particular, say, attributes that somebody's asking about, and then, you know, in research, experimental design, what you can do then is just give choices. Are you meaning this or that? And so on. And of course, going forward, depending on how people answer, I'm wondering, is part of that training that it carries this knowledge forward and keeps improving so that this predictiveness is based on feedback it's receiving from questions?
Yeah, that's a really good question. It does actually. And it's actually, so as someone who works in that area, and we do research and we actually use these tools to evaluate how good they are, for example, in like reasoning and stuff like that. And it's not like reproducible because like for example, OpenAI keeps updating the models because they collect the data that people interact with it, and then they update the model accordingly. And there's also even when it generates an answer, there's a thumbs up, thumbs down. So sometimes if you click the thumbs down, it's going to learn that the answer was wrong and it's going to adjust. And so for us, like if I test it on some reasoning data set right now, I'm going to get some accuracy, and I'm going to test the same model like 1 month from now, and I'm going to get a different accuracy because it keeps improving. But for most people, the most concerning, for most people are just like users of these tools, and they're not evaluating them. For most users, the concern should be it collects your data. Don't provide any personal information to it.
Hi. So I'm interested in what you're going to say about the effect on the labor market, because there's been a lot of media attention around AI taking away jobs, but I've also heard that there are going to be new jobs popping up about prompting, like learning how to prompt, and like all the sectors, like using AI for communications and having people who are experienced in that. So, yeah. Yeah,
okay, thanks for asking that. So I personally think that it's probably going to be a mix of some jobs will disappear, many jobs will change to some extent, and some new jobs will emerge. I don't know about prompt engineer. I think it's some made-up job. It's probably just because there's a hype right now, but I don't think it's going to actually be a thing. But I want to talk actually about, so OpenAI published a report about the potential impact of large language models and generative AI in general on the US labor market. And so what they did was like they had this database of more than 1,000 occupations, and each one of them had like a detailed description of work tasks. And they tried to estimate how exposed each occupation is to tasks that large language models can perform well. And then they define direct exposure as like reducing the time required to perform the task by 50% or more. And then they also consider that users have access not just to LLMs, but also to image generation tools. And so they found that 80% of the US workforce could have at least 10% of their work tasks automated or affected by LLMs. And about 20% may see at least 50% of their tasks. And those would be jobs that would be very substantially changed. And the one, not surprisingly, these models are really good at generating text and code. So any job that requires writing or programming would be impacted, which is very different from like in the past when people would talk about AI automating some jobs. It would typically be more physical labor, like factory jobs. The robots are like replacing factory workers, and now it's more like the people that are sitting in front of the computer and hiring income jobs. So I'm not saying I'm not concerned about that or we shouldn't take it seriously. I think it's definitely something that people and especially like governments and policymakers should take seriously. But at the same time, there's a huge red flag about this specific study that they didn't actually ask people that perform these jobs about the tasks. They hired people. They showed them the description. Like, imagine you're an animal scientist. This is what you do every day. These are the tasks that you do. And then they asked them to estimate how much time would be reduced by using LLMs, which I find impossible. Like, I wouldn't be able to get into the head of someone performing a completely different job than mine and try to see like how well LLMs would be at their job and how much time would be saved. So I find the numbers here like not like reliable, and I would like to like follow up and see if they come up with statistics of real usages. And then there's another point that I think is already impacting people in different occupations. And so it's less about replacing workers, it's more about how it's changing the jobs. So there was this article from Bloomberg that was talking about how LLMs are not going to replace professional workers, but they might put them under greater pressure to be more productive and faster in what they do. And they were basing that on what happened to human translators a few years ago. So in 2016, Google Translate improved a lot because they updated their models. And then there are still human translators because we still need, in many settings, you need a very accurate translation or you need reliable translation, or it's maybe a specific domain or specific languages where the translation model is not doing a very good job. But now, because they have access to Google Translate and other translation models, their job changed from translating to actually correcting the automatic translation. So that saved them time, but then they're also expected to work more productively and probably get paid less. So the same thing could happen to other jobs. It's more, I think this is more like a societal concern. It depends on like how employers would treat this, the access to AI tools.
If I understand correctly, is another word for prompts the types of questions that are asked. So the person asking those questions will come to the table with different degrees of analysis capabilities, critical thinking abilities, et cetera, et cetera, et cetera. So if you were to take, and I'm just using a hypothetical, a group of grade 10 students, depending upon their level of asking those questions or prompts based on their level of critical thinking, what they bring to the table, no differently than just sitting down at the computer and writing a question or writing an essay. Depending on those prompts that they ask, that group of grade 10 students could result in 10 different essays.
Yeah.
So it's really not, in my view, or comment on this, it's not really cheating because they're still being forced to use their skills, if you wish, their critical thinking, et cetera, to come up with an essay. Is that correct? Am I understanding that correctly?
I think it really depends on what the assignment is trying to test. If they just if you give them an assignment, write an essay about I don't know about the history of computer science, and they just go and type that into ChatGPT, and they get very detailed and well-written essay, then they didn't really learn anything from that exercise. But if you ask them to come up with, I don't know, you present them with some topic that has like different angles, or like a debate that has different stances that you can take, and you ask them to choose one of them and to maybe use these models to help generate the arguments against or pro some topic, then it's more involved. Then you could actually teach them how to use these models and like not in a way that offloads the like thinking to the model, but like interactively uses the model and learns from it.
But they would still have to be taught.
Yeah.
If they're just simply using it as a tool and sitting down in front of their computer, if they don't know what they're doing because they're at a lower level of intellect or critical thinking abilities or something like that, they may come up with a lesser quality, or the computer or GPT chat may produce a different essay. In other words, to be more specific, you generated that story about the pet.
Yeah.
If I were to sit down and ask the same, I would have to use the exact same words, would I, to get the exact same essay, or will that story? Or if I sat down and used the exact same words you did, will GP Chat or Chat GPT produce a different story?
So it would actually produce a different story every time, because there's some randomness to the process of generating the text. So even for the same prompt, it would generate a different story every time. And yes, it is sensitive to the phrasing of the prompt, so it would generate different answers. But I think that if the question is very simple, then they could just like input the question from the instructor into ChatGPT and generate an essay, which is not entirely different from like if you ask them to generate an essay about the history of computer science, and they would go into Wikipedia and copy everything. It's just harder to track that, because you're going to get a different answer from every student, and it's actually really hard to. And I actually advise against using these tools that try to predict whether something was generated by an AI or not. So the problem is mostly that it's harder to track plagiarism. Mm-hmm.
And if this work is generated by a language model, it's not their own work.
Yeah.
So academic diplomacy, we're talking about academic studies. So it undermines the whole process of teaching and learning.
Yeah, I mean, I think there's no definitive answers for that. Yeah, there is actually the Center of Teaching and Learning has this webpage about language or like generative AI that addresses these concerns about academic integrity. And at this point, I think it's mostly up to the instructors to define what is the proper use, if at all. I mean, you're also allowed to ban the use of generative AI in your courses. I agree with you. In your case, like if your students are evaluated on generating essays, they need to come up, like they need to be able to do it on their own and not to use ChatGPT. In some other, for example, for computer science, I think if they could just use ChatGPT to generate the entire code, then yeah, they wouldn't learn much. But maybe we could have some assignments where they are like shown shown like code generated by the model and trying to like solve the problem, or so like it depends on what the goal of the learning and the evaluation is. But I agree with you, and for research specifically, I think that I wouldn't feel comfortable if my students would use ChatGPT to generate even ideas for research, let alone the paper itself. Some of my students actually use ChatGPT to rephrase paragraphs for the paper, and I told them eventually you need to be responsible for the text, so you need to go over it and see that it didn't introduce any like factual errors, and kind of harder than that would be to make sure that it's not plagiarized from anywhere. But mostly for rephrasing of short paragraphs, it's not too bad. But at the same time, some journals completely ban like disallow the use of generative AI tools. So I think at this point we still have to decide that, and there's a lot of like individual decisions at this like at the instructor level for courses, or the journal or conference level for research papers, or the supervisors can decide on that. So yeah, I mean, I think we're gonna converge to some like protocol on how it's good, what would be a good use versus a bad use, but at this point we're still experimenting with that.
Thank you for the informative presentation. Just a quick follow-up on the previous two questions, and you already answered some of, you provided some answers. Let's say I'm a student and my instructor asked me to write an essay following on these examples. I use the exact prompt to generate an essay on, let's say, the history of residential schools or any other subject. But I don't turn in that essay exactly like the essay, right? So I go through the essay, use my own critical thinking, check factual accuracy, change a little bit in the essay, make sure the citations are correct. So sort of like, spending some time to personalize and having a feeling that I have contributed to that essay, and then I submit it to you to my instructor. Is it going to be like, from an ethical perspective, from the academic honesty perspective, in your opinion, again, I know our thinking is evolving, but in your opinion, do you think that's something that is okay to do?
Yeah, that's a good question. I think that the answer is probably not, but even though, again, like it's not too different than if you ask someone to write an essay that already has like a Wikipedia page, or like in the past, like, the encyclopedia had an entry about it, and they would like read it and try to write it in their own words. So that's not very different, right? Except for the fact that like it would be different, like it would look completely different for different students. So the teacher can't easily determine that somebody plagiarized. I think the other way around would make more sense, is if you came up with your own ideas about the topic, you wrote the essay, and then you could use it maybe to just improve the writing, or for example, specifically for non-native English speakers, that could actually use with rephrasing. So that would probably be the way to use that is more like it complies better with academic integrity, and also probably teaches the students better about the topic. But again, it's at this point, like it's individual instructors need to decide what they're trying to evaluate, and what level of use of these models they allow.
So is it possible? Like, I don't know, I'm very ignorant about AI. So if I write an essay and then ask the tool to check for accuracy, both linguistic and factual, do you think it will reproduce my essay, and then so that I can compare, probably? And that could be a pedagogical activity with the students. If I'm the instructor, so I can ask the students to compare how, the tool has improved their writing, so that they can compare the kind of mistakes that the students made, so that it's like kind of like a self-learning, So is it possible?
Yes, but I would say mostly for the writing part and less for the factual accuracy.
Okay.
Because it might make up things. So even if they use it for rephrasing just to make it well written. They need to still go over it and make sure that they didn't introduce any factual errors.
Oh, okay, okay. Thank you.
Hi there. Thanks for a great presentation, first of all, and welcome to Green College. I've got two-part question. My first question is, what do you reckon is the future of LLMs if internet is flooded with articles that have been created using LLMs? In 5 to 10 years, you'll have an abundance of these articles, which may or may not be factually correct. And then these future LLMs will be built on those articles. So it'll create this loop of UGC, user-generated content, but we wouldn't know which are correct and which not, which also gives way to a lot of propaganda, because if there are machineries, nation states where they're publishing a lot of articles promoting one side or the other, that I reckon would make it very tedious to figure out what's right and what's wrong. And the second part is, given how certain deep fakes have become quite viral, coupled with how quickly these models are evolving, in 5 to 10 years from now, how would you be able to discern what's true and real versus what's fake and not?
That's an excellent question. Again, and I don't really have an answer, but I can say that it is definitely one of the concerns. I had it in my slides, but I miscalculated how long it would take to go over all the slides. So yeah, one of the concerns of these models is creating misinformation at an unprecedented scale. So it's not like it wasn't possible before the language models to create misinformation, but now you could create these deep fakes, images that go along with the text. It could be used for for not just misinformation or propaganda, but also for phishing emails, fake websites, fake social media profiles. There's a lot of things that it can do, especially now that it for phishing emails, I'm thinking specifically right now I recognize it because it's sloppy. It doesn't look like the real thing, but the better these models get, you could generate something that looks exactly like that and exactly like the real thing. And so that's concerning. And the deep fakes, well, deep fake is video, but I can't remember the name for the audio generation model, but there was a story a few months ago that somebody had a phone call from someone that sounded like her daughter that was asking for ransom or something like that. I don't know how they got the voice samples of her daughter, but that's really concerning, especially for elderly people that could be fooled that way. So that's really concerning. And in terms of the other related point, yeah, it's definitely a problem. So you mentioned that. So yeah, I would say this ecosystem that made LLM so good is the availability of text content online that was created by people and posted for free. So for text, it's blogs and articles. For image generation, it's all kinds of art that is posted and photos that are posted online. And for code, there's GitHub for open source projects and Stack Overflow and example questions for software engineering interviews. And now that these LLMs are so good at automating this content generation, then more of these tasks will be automated. And then people will have even less incentive to volunteer their time to create content and post it online for free. And then the next LLMs will be trained on largely on AI-generated content. So we're going to go into this feedback loop, and there's this position piece that was dramatically phrasing it as we will forever be stuck in 2023. And I think it's not it sounds like it's something in the future, but it's already happening to some extent. So there's the website Quora where people answer questions. I used to answer questions there years ago, and now they added ChatGPT component. So if you ask a question, you have both the human written answers, and also like you have the answer generated by ChatGPT. And if you Google search and this question right now, it's going to show you the AI generated answer from Quora. So you like even when you're doing a regular Google search, you're not using Bing, you're not using Bard, you don't even know that you're getting an AI generated answer. So you can't even trust. Not that it like everything on the internet was reliable before that, but now it could be completely made up. So it's definitely concerning, and I don't know what would be the solution for that, because I didn't mention that, but there are tools for automatically recognizing if a text is AI generated or human written, and they don't really work that well. And yeah, I have some reservations about using them for all kinds of purposes. Yeah.
Thank you.
Oh, sorry, there was. Sorry, what? Oh. So I can repeat the question. So the question was whether they can predict future events. So I think that they could potentially, but I think most of the models are developed in a way that they're very careful. So if you ask ChatGPT, it would say, as an AI language model, I can't predict the future. It has this phrase that it uses, as an AI language model, I can't do something. Sorry? Oh, I think if it wouldn't be, if the developers of the model wouldn't specifically try to prevent it from doing that, I think, and probably even ChatGPT, you might phrase the question in a way that would agree to answer that, so it could tell you the prediction for the future. I don't think it necessarily it would necessarily be reliable or correct. It did have a lot of access to text data, but there's more than the average human knowledge, so maybe. But at the same time, there's a problem in learning from text that you learn a lot about the world, but there's a lot of things that you learn not very well or you don't learn at all. So for example, there's something called reporting bias. So if something is too trivial, people don't talk about it, and then it's not going to be written online, and then the language models would not learn about it. So there's an example, famous example of everybody breathes all the time, we all breathe, but nobody talks about breathing because we take it for granted. And so the language model, I mean, that example is probably appears online, but it's very trivial. So there was an old paper that showed that if you just look at the number of times that each human activity was mentioned in a very large text corpus, breathing was barely ever mentioned, but murdering was mentioned a lot because it's newsworthy, so you want to mention that. But then the model learns this twisted notion of reality where people murder more than they breathe. And then there's other types of knowledge that are not frequently mentioned in text. So when I communicate with you, I also make gestures, I make facial expressions, my tone of voice changes. And a language model just learned from text, so it's blind to all these other inputs. And so there's some perceptual knowledge that you might not be able to learn from text. So yeah, it might give you some ideas on for predicting the future. It's kind of hard to evaluate that. I don't know how accurate it would be, but I guess it could be, that could be a new job that could be created by LLMs.
Thank you for your presentation. Am I correct in my presumption that the prompts that we all give to AI or ChatGPT are then used by the AI to learn? For example, if you gave all the brilliant people in this room an assignment on nuclear fusion and its potential to solve the energy crisis, if everyone else put their prompts in and wrote their essays, and me being me, mine was a day late, and I prompted last, would my essay be more comprehensive or different or better than the rest because everyone else had already contributed?
Yeah, it could. So if the people that generated the essay actually know about the topic, and they either like use the thumbs up or thumbs down to reinforce the model, or they just interacted with, say, oh, I don't think this is correct, or can you make it more specific, or can you make it shorter? It's going to learn and improve from that. Now, I don't know the technical details of exactly how they do that, because, as I mentioned, OpenAI are very secretive because they're monetizing that now. But yeah, it's technically learning, and I've seen it using examples. I'm actually very careful when I use examples in my talks. I'm very careful to, like, if it generates the wrong answer, I never press the like thumbs down or thumbs up, because I don't want it to improve on that example. I want to keep using that example. But yeah, people told me they tested it on a data set of examples, and they got a certain accuracy, and then a month later they tested it again, and it already knows everything because somebody inputted these examples or similar examples, and it just learned that. Which is, for an average user using this model, it's great because it keeps improving. But for scientists that are trying to learn these models, it's a nightmare because it's not reproducible.
Awesome. We burned through that question time, so one more thanks for the speaker.
Thank you.
Thank you for being here. And we're going to move to the reception. Berit is going to stick around if you have more questions. And if you like this series and you want to learn more, I know that there were many people here interested in the education topic. In 2 weeks' time, we're going to have a panel with students and instructors talking about how we should use the models we talked about today. So I hope you see you then. Thank you. Good night.